In this video tutorial, I will explain you the concept of network virtualization. What is network virtualization? How does it work? And what are the advantages for service providers, operators, and you, the end user? A telecommunications network consists of network equipment such as switches, routers, and end-user terminals. They are interconnected via links to enable end-to-end communications. Moreover, large networks such as the Internet consist of multiple separated network domains. Each of these network domains is managed by an Internet Service Provider, or ISP. Network virtualization decouples a traditional ISP role into two independent entities: infrastructure providers and service providers. Infrastructure providers deploy and manage the physical infrastructure and resources. They offer these resources through programmable interfaces to the service providers. Service providers, on the other hand, lease resources from infrastructure providers to create and deploy virtual networks. They combine and program the allocated resources from multiple infrastructure providers to offer end-to-end services to users that span multiple network domains. To offer such services, the owner of a virtual network can deploy custom packet forwarding, routing protocols, and control and management planes. Additionally, the service provider can recursively provide virtual network resources to other service providers and act as a virtual infrastructure provider. So as you can see, the virtual networks form an overlay on top of the physical network domains. Virtual nodes are mapped onto physical nodes. Moreover, multiple virtual nodes may be co-located on the same physical node. In this case, the resources of the physical node are split among the virtual nodes it hosts. Possible node resources that could be virtualized include CPU, memory, and router queues. Virtual links, on the other hand, are mapped onto a path of physical links. Multiple virtual paths may overlap in terms of the physical links they use. The link resource most often considered is bandwidth. Moreover, virtual links may have constraints, such as maximum delay or packet loss. A major theoretical problem in network virtualization research is virtual network embedding. The goal is to allocate and schedule physical resources among multiple co-located virtual networks. In other words, the problem consists of mapping virtual nodes and links onto physical nodes and paths, taking into account the virtual network resource requirements and the physical network resource constraints. This problem can be modeled as a mixed integer program, or MIP, which is known to be NP-hard and thus scales exponentially in terms of the computational complexity. Due to this high computational complexity, many heuristics have been proposed that provide near-optimal solutions. These heuristics can be divided into groups based on several characteristics. First, we can consider static versus dynamic embedding heuristics. In the static case, it is assumed that a virtual network request is known beforehand. This is the most basic and easy to solve version of the problem. In contrast, a dynamic heuristic can handle the arrival of new virtual network requests during operations. In this case, it is necessary to reallocate previously embedded virtual networks in order to achieve the optimal solution. This is obviously non-trivial in production networks, as a path of active data flows in a network needs to be changed on the fly. This can result in packet loss and temporary performance degradations. A second important characteristic of embedding heuristics is their distributed nature. In case of a centralized heuristic, a single entity is responsible for calculating the virtual network mapping. The advantage of this approach is that this entity has a complete view of the physical and virtual networks, which facilitates optimal embedding. The associated disadvantage is that this complete view becomes a scalability problem in case of very large networks. When a heuristic is distributed, multiple entities calculate a solution for part of the network. By growing the number of algorithm instances with the size of the network, scalability can be maintained. When multiple physical network domains are involved, a distributed solution is essential, since they generally do not like sharing detailed information about their internal network structure and resources with each other. The third and final distinguishing factor concerns the amount of redundancy that is introduced. In case of a concise embedding, only the exact amount of requested resources are allocated to a virtual network. Some heuristics, however, allocate more resources to a virtual network than originally requested, which is referred to as redundancy. Redundancy reduces the negative effects of physical resource failures on the deployed virtual networks by providing virtual backup resources that map onto different physical resources. To summarize, network virtualization provides an abstraction of the physical network infrastructure and its resources. Introducing such abstraction layer has several advantages. First of all, virtualization allows multiple network architectures and protocol stacks to coexist on the same physical network infrastructure. This also facilitates the deployment of new and experimental network technologies without endangering or disturbing existing services. Second, network operators can use the provided abstractions to manage and modify their networks in a more flexible and dynamic way. Network topologies can be reconfigured on the fly and new protocols and services deployed without disrupting other traffic. Third, intelligently allocating physical resources to virtual networks allows the quality of service constraints of services, such as bandwidth, delay, and packet loss, to be guaranteed. Virtual network embedding heuristics that are capable of transforming these constraints into suitable virtual to physical mappings are indispensable to achieve this. And finally, for more information, I would like to refer the interested viewer to two scientific publications, on which the information I presented in this brief tutorial is based. First, State-of-the-Art and Research Challenges on Network Virtualization by Chowdhury and Butaba. And second, a survey on virtual network embedding by Fisher et al. Thank you for watching.